Hi guys, you welcome to my channel. So as you're about to write your JAMB exam now, I think there's need for you to focus on what exactly examiner is looking for. And that's the reason why I quickly want to take you through this topic that you cannot escape it. And oftentimes you always create phobia for this particular topic despite the fact that it's quite simple. However, I'm going to be taking you through the topic right now, and I'll summarize it in the way that you are going to understand it. So let's get started. Now, what topic am I talking about? Equilibrium of forces. Equilibrium of forces. Now, when you talk about equilibrium of forces, what exactly do you need to understand about this topic? That is, what examiner wants to ask you on this very said topic. It starts from the definition of equilibrium itself. When is a body said to be at equilibrium? This is what you just need to understand. If I tell you that this body is at equilibrium, what it simply means is that the total force, that is, the total force, if the examiner did not want to use the word total, they can use the word net force. Net force. If they don't want to use the word net force, they can use the word resultant force. Resultant force. So when the total force or net force or resultant force, either of these three, any of them that they use, as long as the total force that is acting on a body is equal to zero, that means the body is at equilibrium. Now, most times, examiner will not come directly to throw it to you like this. They might bring it in terms of a question, maybe calculation. Just know that when they tell you that this body is at equilibrium, what it implies is that the body is acting under a force that the sum is equal to zero. That is, the total force that is acting on that body is zero. Anyhow you want to say it, just know that all the summation of the force on that body is zero. That's when the body is said to be at equilibrium. Now, examiner will now want to ask you the types of equilibrium that we have. When they ask you about the types of equilibrium that we have, which is the second thing that they might want to test you on, if they know that you understand the definition of equilibrium, to further what? Be sure that you know it. They want to ask about the types of equilibrium. When they say types of equilibrium, we majorly have what? Two. And that include static equilibrium. Static equilibrium. We also have dynamic equilibrium. This dynamic equilibrium, they can also call it kinetic equilibrium. So the word dynamic, the word kinetic, it has to do with something that is moving. Am I making sense now? So let's focus on this very first one, that is static equilibrium. When they say a body is static, it means the body is not moving, which is the same thing as stationary. So if they use the word stationary equilibrium, it's the same thing as the word static equilibrium. You just need to understand that. Now, when is a body said to be at equilibrium? When it's static. That is, when the body is not moving, how are you going to know that that body is at equilibrium? So when the body is not moving and they tell you that it's at equilibrium, what it means is that the body is at rest and the total net force that is acting on that body is equal to zero. Or you say the body is at rest and the net force on the body is equal to zero. Or you say the body is at rest and the resultant force acting on the body is equal to zero. So you can see, they can use any of the three words. Just understand that the body is at rest, that's what makes it static. To make it equilibrium, the total force is equal to zero. I hope you get this clear. Cool. Now, for dynamic equilibrium, it takes more than the force for the body to be at equilibrium. You have to know that. But for the first thing you need to know is that since it is dynamic, or they use the word kinetic, it means the body is moving. That's the first thing you should know. Now that you know that the body is moving, what are the conditions to make the body to be at equilibrium while moving? Number one, you say the speed or the velocity of the body, the speed or the velocity of the body must be uniform. Must be uniform. So that's the first condition. So if the speed or the velocity of the body is at what? Is uniform, that is, it's not increasing, it's not decreasing, it's steady. Then the second condition is that what? The net force acting on the body. The net force acting on the body is what? Is zero. Are you getting it now? So if the net force acting on the body is zero and the body is moving with a uniform speed or uniform velocity, then you say the body is at equilibrium. What type of equilibrium? Dynamic equilibrium. Do you get this now? Or you call it kinetic equilibrium. Now, it's not possible because examiner might want to confuse you. It's not possible for a body to what? To possess a dynamic equilibrium and a static equilibrium simultaneously. It's not possible. Why am I saying this? Is that sometimes we might want to refer a body that is moving with a uniform speed as a body that is not moving. Am I making sense now? That is, a body moving with a uniform speed can be what? Categorized as a body that is not moving. So don't use that to confuse yourself, thinking that static equilibrium and dynamic equilibrium can occur simultaneously. No. Is that the body is what? Is static, or the body is moving? And I hope you understand the condition for it now. Awesome. Now, the next thing that you now need to understand under this topic, after you get this clear, is to understand what we refer to as moment. Moment. Now, when I say moment, what exactly do we call moment? We need to understand the difference between moment and moment of a force. However, we always use the two interchangeably, especially in an objective question. Am I making sense now? In an objective question, just like the JAMB exam you are preparing for, moment and moment of force usually use interchangeably. However, you should know the difference between the two. When they say moment, moment simply means the turning effect of a force about a point. That's moment. The turning effect of a force about where? A point. But when I now say moment of a force is the product of the force and the perpendicular distance. I hope you understand it too now. However, oftentimes, in more cases, generally, they call moment as the product of force and perpendicular distance. Do you understand that now? Moment is the product of force and perpendicular distance. Now, I want you to understand something here. What this simply means is that if I have a body like this, let's say this is a body, and you apply the force like this. This is a force, and this is the body now. You apply this force, you apply this force on this body like this. Are you seeing this now? This is the force you apply on this body. Now, this force, if you look at it, is at 90 degrees to this particular body, right? That means the force is perpendicular. So if you want to know the moment of this force, what's the perpendicular distance from here to this point? Let's say this one is what? X. So the moment of this force is now going to be what? Moment of this force is going to be force multiplied by what? X. Do you understand that now? So that will be the moment. Now, when you apply the force to a body and that force is not perpendicular, if that force is not perpendicular, that means that force is said to not be what? In moment. I don't know if you get where I'm coming from. Let's take, for instance, that you have a body like this. This is a body. Let me say this is X and this is Y. And then from here to this place, let's say this is point small letter y, and this is 2 centimeter, and this is a force of 5 Newton, for example. So if you look at this force of 5 Newton and you look at what the distance of this 5 Newton force, you can see that it is on the same line as that of the body. It's not perpendicular to it. Moment of this 5 Newton force is going to be 0. Why? Because it's not a perpendicular force. Am I making sense now? So I think I'm going to drop a link to what's it called? The video under moment so that you get to understand it better. I'll drop it in the description part of the video. Then you can watch it and see various examples and situations in which this can occur. But what I want to focus on here is basically for you to understand that moment is a product of force and perpendicular distance. I hope you understand this now. All right, so that's good. That's cool. So if we understand that right now, what's the next thing we should do? Now, I think let's see something. Let's take, for instance, that I have a body like this. Let's say I have a body like this. And I'm going to put you in suspense with this now. I've said it before that once the force is on the same line as the body, then there is no moment, right? Because the force needs to be perpendicular. Now, what if I have this? Let's say this is a body here, and I applied a force like this. Let's say I apply this force F like this, and I have this place to be theta. Are you seeing it now? So this force F has a vertical force. So let me say F sub y. And the distance from here to this place, or don't let me even put it like that, because the question will usually come in this manner. Like this, just like this. You have something like this now. Let's say maybe there is a body here, and let's say this body is 5 kg, and you're giving a force F that is inclined at a particular angle here. They now ask you to find the moment of this force. You cannot tell examiner that this force is not perpendicular to this, therefore the moment is going to be 0. Although you find 0 to be part of the option. Do you understand? Because they know you already understand this. They now want to test you further. Now, the answer to this one is not going to be 0. Do you understand where I'm coming from now? Why? Because this force has a vertical component. This force has what? A vertical component that is acting on this body. So you need to find out its equivalent vertical component to calculate for your moment. I know you are curious for me to show it. Check the description part of the video. I explain this in detail in that video. So you'll be able to derive this and solve it. So let's move on, because I don't want this video to be too long. And what I quickly want to show you right now is condition for bodies to be at equilibrium. Now, when you talk about body being at equilibrium, there are several cases for a body to be at equilibrium. When a body is floating on water, condition for that body to be at equilibrium is different from when a body is neutral. And it's different from when a body is acting under the influence of parallel forces. And when a body is acting under the influence of non-parallel forces. Examiner want to test you on all of these conditions. So how do you know which is which? Let's see. Now, let's start from the very first one, which you all know, and that is when a body is acting under the influence of parallel forces. So when the body acts under the influence of parallel forces. Now, what are the conditions for this body to be at equilibrium? Now, I'm going to be explaining something to you about the calculation here, because there's a calculation. So I want you to understand something about the calculation so that you can handle any question under this. Let's go. Now, when I say a body is acting under the influence of parallel forces, what does that mean? What it means is that the body is positioned in a way that the forces that are acting on this, none of them can touch each other. I hope it's clear. Okay, I want to believe that it is, but let me show you. Let's say I have a body here. this is a ruler. Let's say this is a ruler. That is meter rule. And it's suspended on a knife edge at center of gravity G. So if this is what I have, let's say a force F1 is applied to it here, and a force F2 is applied to it here. You see this F1 and F2, no matter how you want to draw them, they cannot meet each other. Abi, since they cannot meet or touch each other, that means they are parallel. So for this body now, is acting under the influence of parallel forces. Now, is this the only case? This is not the only case. You can also have another force acting upward like this. Let me say this is F3. You can as well have another one like this. Let's say this is F4. Are you seeing it now? So you can see all the forces, both the one acting upward, both the one acting downward, they cannot touch each other. So what are now the conditions for this body to be at equilibrium? That is body AB. Let me call it body AB. For body AB to be at equilibrium under the influence of all these parallel forces, what are the conditions? The conditions include, number one, that the upward force, that is, the sum of the upward forces must equal to the sum of the downward forces. That's the first condition. Upward force, let me put it the other side. Upward force must equal to downward force. That's the first condition. Take it down. Upward forces must equal to what? Downward forces. And common sense can tell you that you should be able to remember that. Because if the force that is acting upward is greater than the force that is acting downward, it means this body is going to pull up, right? And if this one is greater than the one that is acting upward, it means this one is going to pull it down. So for this body to stay horizontally balanced, this one and this one must what? Be equal. Sum of the upward force must equal to the sum of the downward force. That is one condition. Now, I'll tell you when to use and how to use all these conditions for your calculations. Now, what's the second condition? The second condition is that the algebraic sum of the forces acting on this body must equal to 0. That is, the net force acting on the body, must equal to 0. That's the second condition, guys. What's now the third condition? I know somebody's about to tell me now. Correct. The sum of the clockwise moment must equal to the sum of the anti-clockwise moment. Yes. What do I mean? When I say moments, you need to understand how to go about it. Whenever you are dealing with calculation under equilibrium, all you just need to do is to pick a reference point. What do I mean by a reference point? That is, you want to pick a point that you'll be considering the distance between that point and any forces that you want to consider. Let's take for instance that we pick this place to be our what? Our reference point. That is this point G. It's our reference point, right? So if we want to talk about F1, we are going to consider the distance from F1 to that G. Let's say it is called X1. Or let me call it D1. Yeah, let me call it D1. And for F2, instead of you to consider the distance of F2 with another point, you also consider the distance of F2 from that reference point. So that means I'm considering the distance of F2 from this reference point here. So I'll call this one D2. So if I want to consider the distance of F4, where will I consider it to be? Yes, it shows that you now understand. It has to be from here, which is this same point here, to where I have what? Where I have the force F4. That will be D4. And for this one, it's going to be from here to this place, which is what? D3. Do you understand that now? So if the question says taking moments about this certain point, what it means is that use that point as a reference point. Whatever force you are considering, it has to be the distance away from that point. Do you understand that now? Good. So when we now talk about moment of F1, moment of F1 is going to be what? The product of this perpendicular distance away from this reference point. The product of this perpendicular force away from this one reference distance here. Do you understand where I'm coming from now? So that will be this one is going like this. This times this. Am I making sense now? So for this one, it's going to be like this, right? And for this one, it's going to be like this. And for this one, it's going to be like this. Are you seeing it now? I believe somebody is getting to understand physics. Correct. So, boy. Now, watch. We now have what we call clockwise and anti-clockwise. What does these two things mean? Clockwise simply means the way the clock is turning. Anti-clockwise means the other way around of the turning of the clock. Now, your clock, when you check your time, when you check your wristwatch, it's, this is 12, this is 6, this is 3, this is 9, and this is the second round. It's always read like this, right? Isn't it? So this is clockwise. Anyone coming in this manner is what? Clockwise. And this is going to be counterclockwise or anti-clockwise. So anyone coming in this manner is going to be what? Anti-clockwise. So yeah, guys, this one is going to be what? Anti-clockwise. And this one is going to be what? Clockwise. This one is going to be what? Okay, me too. I want to get it confused now. This is what? Anti-clockwise. And this is what? Clockwise. Have you seen it now? So what this third condition now states? This is the first condition. This is the second condition. The third condition for this body to be at equilibrium now states what? The moment, that is the clockwise moment, the sum, let me put it like that. The sum of clockwise moments must equal to the sum of anti-clockwise moment. Correct. That's the condition. Sum of the clockwise moments must equal to the sum of anti-clockwise moment. What do I mean? What it means is that, the moment of this F2 is going to be what? F2 times D2, right? Which is clockwise. This is the clockwise moment here. F2 multiplied by D2. Abi? Now, which other clockwise do we have? F3. Abi? So the moment of this one is going to be F3 times D3, right? So plus F3 times D3. So this is going to be the sum of clockwise moments. Now, for anti-clockwise moments, I'll be having what? F1 times what? D1. So F1, D1 plus F4 times D4. F4, D4. So this must equal to this. That's what they mean by the sum of the clockwise moment must equal to the sum of anti-clockwise moment. And that's the condition for this body that is acting under the influence of parallel forces to be at equilibrium. I hope it's clear. All right. So if this is clear, you cannot undo any questions on that moment. So the question usually being that what will be the force that will make the body balance? You just do this and make that force, the unknown force, the subject of the formula. What's the distance of what distance can you place the force for the body to be balanced? Just find the what? The particular force. Okay, maybe they gave you this one, they gave you this, they gave you that, and they're asking that where are you going to put F2 in order for F2 to balance? Same thing, just find the value for D2. Very simple. Don't worry. I got you. I've solved enough questions under this topic, and you can find it in the description part of this video. In that video you find there, I solved a lot of questions there, so you have nothing to fear. All right, good. So let's go to the next one. Which one is that? That is condition for equilibrium of a body. Condition of God. Don't worry, I'll remember. Condition of equilibrium of a body acting under the influence of non-parallel forces. So when a body is acting under the influence of non-parallel forces, what does that mean? When I say a force is non-parallel, it means that force, when you draw it, there is likelihood or they are going to touch each other. Do you understand where I'm coming from now? Let's take for instance that I have a body like this. This is a force, and this is a force, and let's say this is a force. Have you seen these forces now? You know they are not touching each other. But if I decide to draw this one like this, and I decide to draw this one like this, and I decide to draw this one like this, you know, at a point, they meet each other. Am I making sense now? So since they can meet each other, that means they are non-parallel. So when a body is acting under the influence of a force, that there is likelihood that they can touch each other. That is what we say the body is acting under the influence of non-parallel forces. Show you what. All right. So I believe it's clear. So if it is clear, what are the conditions for the body to be at equilibrium? Number one, the first condition is that they must be, it is a must, they must be coplanar. Coplanar. I don't know if that spelling is correct, but I'm sure it's correct. They must be coplanar. That English is too much. Yes, even for me, it's too much. I'll break it down. When I say they must be coplanar, it means that they must not be parallel. They must not be parallel. If you don't want to say that they must not be parallel, well, you can say they must touch each other. Physics is sweet, bro. Have you seen it now? If you don't want to say they must what? They must not be parallel, you can say they must touch each other. That's what I mean by what? They must be coplanar. Do you understand where I'm coming from now? So the second condition is that what? They must be concurrent. They must be concurrent. What do they mean by they must be concurrent? They must be concurrent means what? They must meet at a particular point. That is, they must be concurrent means they must act at a point. When I say they must be concurrent, it means they must what? They must act at the point. That is, they must have a common point of reference. And thirdly, who can tell me of the third one? Thank you, God. That means what? They can be represented. They can be represented by the adjacent side, by the adjacent sides of a polygon, or you can say triangle. So I want to say just triangle before, and that's why I just say polygon. So, but however, the reason I put triangle, I'm not supposed to put triangle because I already put polygon. So you can just, but I don't want any form of argument. That's why I just do the tautology. Yes. Anyhow, most textbooks usually say that what they must be what they must be they can be represented by the adjacent side of a triangle. Why would textbooks say that? Is because most times all these non-parallel forces, they usually come in form of 3. So when they come in form of 3 like that, you must have seen questions similar to that. Let me show you one. You must have seen the questions that looks like that. Like you can have a body like this, and you're going to have something like this. Then you have something like this, and you can have something like this. Are you seeing it now? So let me say 5 Newton, let me say 6 Newton, let me say 7 Newton. However, you can see these 3 forces now, these usual ways that questions underneath usually come. So you can just say this one is going to be the third side of the triangle. So you have this. So you can see 7 Newton, 5 Newton, and 6 Newton. So that's why I would say they can be represented with 3 sides of a triangle. But I'm just thinking ahead that what if they are more than what? If they are more than 3. So that's why I use the word polygon. I hope it's clear. So that's that for equilibrium of a forces. Now, how should you handle questions under this? Is there any question that is coming under this that you cannot answer again? None. But there is still one. And what's that one? That is what they call couple. Now, examiner can ask you that what is a couple? When they say couple, couple is anything that has what? That has equal and what? Parallel forces. Am I making sense now? Equal and parallel forces that are acting opposite to each other. I'm trying to make it as simple as possible so that if they bring any English, you will be able to break it down. When I say something is a couple, let's take for instance that, okay, for example now, this marker now this cover of this marker is a couple. Why? If I rotate it like this, let's say I'm rotating it like this. Now, if I rotate it 10 times like this, I have to rotate it backward 10 times for me to open it back. So anything that behaves like that is a couple. So you can see that it is equal and opposite parallel forces. Equal and opposite parallel forces. That's what we refer to as a couple. So they can now ask you that what is the moment of a couple? Moment of a couple is what we refer to as tug. Moment of a couple is referred to as tug. They can now ask you that the motion performed by couple is related to what? You can refer it to what? Rotational motion. Do you understand where I'm coming from now? And that is majorly everything that a summary of everything that examiner want to look at under this topic. If you want to see the full topic, where I solve enough questions and makes detailed explanation and give what? Exact definition of everything, check the description part of this video. However, everything you need to know about this topic is what I have summarized here. So I didn't talk about center of gravity, right? I talk about it in that video. And when I say center of gravity is just basically where the net force acting on a body tends to concentrated at. Am I making sense now? So if you apply force on a body, where are those forces tends to concentrate at? That is what they refer to as center of gravity. Now, how can you determine the center of gravity of bodies? Because they can ask you that what will be the center of gravity of a square? So how do you know? It's very simple. Just do what? Draw a square like this. Apply a force here. This is a force here. Let's say this force here is F1. Apply a force here. This is F2. Apply a force here. This is F3. Apply a force here. This is F4. Are you seeing it now? Draw this force towards this side and draw this one towards this side because they pass through the same line. No problem. Draw this force towards this line. Draw this one towards this line. That point where the whole of the line intersect, that's the center of gravity of this body. Am I making sense now? So if you have what? If you have, what's it called? A circle, and you're looking for its center of gravity, it's simple as well. Just find the what? The diameter on the vertical axis, the diameter on the horizontal axis, and of course, it's going to be at the center of the circle. What about triangle? If it is a triangle and you're looking for a center of gravity, draw the nonsense like this, draw this one like this, draw this one like where the three lines intersect is their center of gravity. Now, what if it is irregular body? Check the video in the description part of this video. Then you are going to see how to go about that. And I want to believe that we have done justice to this topic to a point where you can use this to pass your JAMB with ease. So if you have any question, you can drop it in the comment section, or any contribution, drop it in the comment section, or you just want to tell me thank you. I will appreciate that a lot. So drop it in the comment section, and that will help this video to even go viral. That means you also have to share. And if you have not subscribed to this channel, what's stopping you? It won't cost you anything. Subscribe, because I'm going to dish more